standing. Are you okay? Okay, now you can go back to your chat.
Being promoted to full professor every 7 years would effectively come and present a colloquium and talk about their careers and plans for the future. And so the ELT reviewed this, approved it, and decided to have this pilot. And we're very happy that Carol Handwerker in material science and engineering agreed to participate in it. And so we're looking forward to the wisdom that she's going to share with us. Carol, thank you.
Thank you very much, Claude. So there are a lot of students in here today, some of which have been assigned to be here as part of the materials engineering teaching experience, but others I see just from our classes from across the College of Engineering. So thank you for coming today. One of the reasons that I was excited about doing this was that Purdue, I don't know if you know, is really an incredibly wonderful place to be. And I think it's really made my life so much, I don't know, more fun. I was telling Claude that this talk is supposed to be about having fun, and we are going to have fun here, hopefully hearing about some of these things. But they worked on my husband, John Blundell, and me for about 12 years before we came here 7.5 years ago. So 7.5 years post-tenure for us. And they have always worked hard to make sure that from the very beginning, when they were trying to get us to come to Purdue, which was 12 years before we showed up, they wanted to make sure that we really felt like a member of the Purdue family. So every time we go to a conference, they'd stick a Purdue sticker on our badge. And I didn't really realize how subtle they had been until we showed up here. We went to the first Purdue women's basketball game of the season, and the band started playing. And I turned to them and looked, and they were playing the Purdue fight song. And 12 years before then, I had come to Purdue to give a seminar, and they gave me a Purdue clock, an alarm clock, and I had been waking up to the Purdue fight song for 12 years. So it's not just about the courses we teach. It's about the community that we belong to and the groups that we become part of to try and do things that are larger than ourselves. And I can't imagine a better place to do that than here at Purdue. And so I'm going to talk to you today about sustainable electronics. And I've subtitled it the Canary in the Coal Mine for planet Earth. And we'll get into that in a minute. I'm going to show you a little bit about sort of how I came to this view of the canary in the coal mine. You'll see this picture later. Is they used to take canaries into the coal mine for the coal miners because they were the canaries were very sensitive to methane and other poisonous gases. So they would feel the effects before anything else would. And so if the canary died, the word was you got the hell out. So this is my view on what the canary in the coal mine analogy is for sustainable electronics. And we'll get there in a few minutes. So I started working on electronics a long, long time ago. So this is when I was at the National Institute of Standards and Technology. This is a timeline. So it says NCMS there. It was a major program in the United States that I became part of in 1993. And that was because they were going to ban the use of lead in manufacturing in the United States. So it was just for manufacturing. So there are a bunch of us who got together that wanted to see, all right, what would this mean to electronics manufacturing? And you may recognize some of the names here: AT&T, Ford, General Motors, Hamilton Standard, which is part of United Technologies, NIST, which is where I was, Electronics Manufacturing Productivity Facility, which was in Indianapolis, RPI, Rockwell, Sandia, and Texas Instruments. So from 1993 to 1997, a team of us got together. It was, in those days, an $11 million program. It was all in kind to see what nature would give us if we had to remove lead from sort of our toolkit. This was the team, and I don't know, can you pick me out? Anyway, I wore glasses in those days before LASIK. But this is the team smiling at our final meeting, where we were celebrating the fact that we had written this report that really laid out what the alternatives would be if we could no longer use lead. And it was sort of a hallmark of the things that I like to do even now, which is I love working in teams. I think I can see here my two members of my senior design team right there. I really love working in teams to see what the larger group can come together to do that we could not do individually. And many of these people have remained my close friends even now, so 97. Well then, they decided the bill was a bad idea. So there was a gap between 97 and 99, and other groups were still doing work. I wasn't part of the NCMS high temp project. I handed that off to one of my colleagues at NIST. But then in 1999, the European Union decided to ban the use of lead in electronics. So at that point, the United States had a major program through this big consortium project, through NEMI, fondly known as NEMI. Then it was the National Electronics Manufacturing Initiative. It has now become INEMI for international. But at that point, we had to have a substitute for tin lead, eutectic solder. And we had to have the substitute within 2 years, and we had to be prepared to manufacture it in that time. So going from one technology to another, 2 years was the full transition time. So this is what we were part of. So because of my earlier experience, I helped run the solder alloy evaluation team from before. I was in charge of solder alloy selection, but also the team that dealt with the scientific parts for all of the rest of these. And this represented all these different companies. Again, some companies whose names you'll recognize. Intel is there in some places because they make products as well as have components. Motorola and NIST is up here. So this was the group that was involved in doing the technology transition. So we were able to do this. We determined what the best possible candidate alloy was based on thermodynamics, kinetics, worked on reliability. I didn't hand polish the samples, but I but I actually measured the resistance of all the individual joints on all the different samples. That was how I got in the lab in those days when I was the division chief at NIST. So, at that point, then it was an issue of lead-free implementation. So these are the teams that I've been involved with since coming to Purdue. So there have been an incredible number of problems with implementing lead-free. Lead-free solders are not just drop-in replacements. They don't behave the same. They aren't as reliable. They're harder to process. And I'll come up with a few environmental things later to show you what some of the other issues are. So I've listed here my collaborators, John Blundell, Ganesh Subbarayan, Mysore Dayananda, Eric Stack, Elliot Slamovich, and Rakesh Agarwal from this part of my, the work that I've been doing in research, and then all of our wonderful students who've been part of this. So this is just in really dealing with the issues of this technology transition to lead-free. I'm not going to go into a technology talk on lead-free. I actually started putting slides together, and I ended up with 120 slides. And so I removed all the technical ones, but as we were starting to look at issues very early on at Purdue about lead-free electronics, we could see that it dealt with just more than a technology transition. That, yeah, you could come up with new technologies, but there were a lot of other issues that were coming up. Once we showed that in lead-free we could substitute a material, now people wanted to substitute lots of different materials. And the question was whether they were any better environmentally, or for human health, or for performance. And we just didn't know. And we also realized that there were a lot of other areas. You can see in this list, this is the Sustainable Electronics team at Purdue. And you can see there are a lot of different expertise that are represented there. Karthik Ramani is here, and he's in sustainable design, really looking at some far out things, including origami-based electronic design. We have anthropology with Corey Cooper and Ryle Nolan, who are dealing with consumer behavior, because all of those things enter into whether electronics can be sustainable or not. So we slowly started putting this team together. This is the team as of today, but we first put in a proposal for an IGERT, an Integrative Graduate Education and Research Traineeship in Sustainable Electronics. We put, I think the first one was in 2006. And as you'll see in a minute, we were awarded it in 2012. So it took us some time to really decide what kinds of topics that needed to be included, to put the team together, and to also begin to work to see what kind of differences we could actually make. We've also done this in close collaboration with faculty from Tuskegee University. So we have 5 faculty members who are part of the IGERT, who are from Tuskegee. They're in the Material Science and Engineering Department, and they offer a PhD program there. And they've been with us I guess, for the last 3 years in honing this proposal and developing relationships that we can build on in the future. So we started in very small ways. Let's see, are any of the people who are part of this first topic recycling Lcd Tvs? We had 18 undergraduates from material science, mechanical engineering, communications, and anthropology working on this project. It was with Fu Zhao and Corey Cooper and me for 3 years, trying to understand what some of the interdisciplinary issues there were in sustainability. And through all of our work together, very recently, starting last June, we were awarded 2 large grants. One, the IGERT, which I mentioned, a Global Traineeship in Sustainable Electronics, with Inez, Ananth, Karthik, and Mahesh Hazur as co-PIs. And we were recently awarded the Critical Materials Institute Award from the Department of Energy. It's an energy innovation hub, which is part of AIMS. So what we're trying to do with this is that we're trying to make sure we have all of these different parts of the equation for sustainability in place. So Ananth Iyer, I was looking around thinking, oh wait, you might not know who Ananth is. Ananth is a professor of management, and he's an expert in supply chain management. And John Sutherland is way up there at the top. Hi, John. He's had an IGERT before at Michigan Tech. He led it. And so he actually has developed models of the societal basis for sustainability. So anyway, we have quite a team here that we're able to work on a number of different topics. So I'm going to share with you, okay, so that's just sort of the background. Here's who we are. Here's the team, the great team that I work with, the students, the faculty members, and all these different areas. And now I'm going to tell you a little bit about our view of the canary in the coal mine. So here are some pictures, some real pictures of canaries in coal mines. So why do we think that, that electronics is that canary? Well, it's a slightly different view of sort of the warning signal. I mean, we all know that there are water issues in the world. There are food issues, food shortages, drought, all sorts of sustainability issues. But in those cases, a lot of times the problems seem very hard. And we are not so connected to those other places that are having food shortages or water shortages. You know, that we hear more about them all the time, but I don't know, it seems a little bit more remote. To me, electronics is something that we really have a choice as to whether we use or not. So when we are saying, and I'll show you in a bit, that the electronics we buy have this effect on all of these people, on all of these regions in the world, and we are using their resources, it is a test of us to see what that means to us. What are we willing to accept and what aren't we willing to accept? So it's not a literal canary in the coal mine, but it's a personal one that says, am I willing in my ability and choice to get a new cell phone, what does this mean to people in other parts of the world? And if I say that about food, I mean, we're willing not to address those things, but I think in terms of electronics, as much as we all love them, and as we all have them, I'll show you some statistics to show you how much we love them, that it is a choice beyond what we normally think of as for food and water and shelter. So I'm going to share with you this view of what global sustainability looks like for electronics or for any other technological system. We'll see what kind of guiding principles there are, how do we measure it, how do we begin to frame the right questions for these. Looking at some of the trade-offs. I mean, these are some of the things that we are trying to figure out within the IGERT. What data are not there? How do we apply these concepts at the research stage? And acknowledging at the same time that we don't know what this looks like, But we want to understand, we want to eliminate barriers, and we want to be able to build bridges so we actually have an effect on what's done in industry, NGOs, government, within education, and that we will be part of those, and the students will be part of that. All right, so this is the definition of sustainable development, and it's where we meet present needs without compromising the ability of future generations to meet their needs. And this is a standard, beautiful picture of it, a landscape, and sustainability is not just, though, about environmental side of sustainability. If you read within the original description, so where this quote came from, it was from the UN World Commission on Environment and Development. They originally said, it's development that meets the needs of the present without compromising the ability of future generations to meet their own needs. But they said it contains within it two key concepts, the concept of needs, in particular the essential needs of the world's poor. So if we don't look at that other part, I think we can all feel very complacent. Well, our children are going to be fine. Well, this is the world's poor, the world's children, to which overriding priority should be given. And then the idea of limitations imposed by the state of technology and social organization on the environment's ability to be present in future needs. So it's about society, technology, and equitable access to resources. So in sustainability, this is known as the triple bottom line. So there are all sorts of analogies, the triple bottom line, the 3 pillars of sustainability. In the triple bottom line analogy, it means that all of these are going to be summed up. And I don't know, in the triple bottom line, I have this image of St. Peter tallying things up at the pearly gates. Anyway, so there are 3 different parts. Here is this image that we've modified from the 2002 University of Michigan Sustainability Assessment that shows these 3 types. So we've got the environmental sustainability, which is the things that I think a lot of people think of in terms of Greenpeace, available natural resources, ecosystem health, climate stability. But you can't have stability, even in the short term, unless you also have some opportunity for some economic opportunity, whether it's for growth or at least staying static, manufacturing, employment. And then the 3rd pillar is education, access to food, clean water, shelter, health care, government stability. And then we have regions in which all 3 of these, or 2 of these, for example, overlap. Excuse me. And so, for example, here between societal and industrial economic, we've got fair trade, workers' rights, and having individual people's opportunities. So sustainable development is meeting these needs. It includes these 3 topics, and one of the things that we're forced to look at is to actually define it's sustainable for whom, over what period of time, where we understand that any particular impact is the impact times the number of people that it impacts. So, okay, so this is why this electronics is the canary in the coal mine. There are, when I looked up the statistics today, 1.6 billion global 3G subscribers. There's 6 billion mobile subscriptions worldwide. That was in 2011. And we have a population of 6.9 billion. 78 out of 100 people in developing countries have cell phones. So electronics become a need on one hand, and a choice, and I will say, what do you call it? it's not a frivolity anymore. It's something we all are beginning to depend on. But all of these systems require incredible amounts of material resources. They also require a global supply chain. So this was a simplified schematic for one product for one manufacturer. And this shows where the component manufacturers are, the raw material suppliers. It is truly global. And it does involve societal issues as well. So here's a picture of a Foxconn factory in China. And the choice of technologies that one makes affects people in many ways. Here is a factory in Taiwan. So we have, on the societal side, we have many people being employed under a variety of different work conditions, or fewer people being employed here, but more people being employed to build equipment. So when we look at any of the products that we're designing, and these cell phones are being made only really by a few companies in the entire world, then the environmental impact is being felt over an entire population. We have many different impacts that we have impact to have our needs met. We want food, shelter, water, safety. We also want the ability to develop communities. So I have had the privilege of communicating some with Dennis Meadows. Dennis Meadows won the Japan Prize in 2009 for his groundbreaking work in sustainability. And so I'm going to use a few of his slides. So once you start doing the sums and trying to figure out what the actual impacts are, one has to actually get really excellent numbers for these and try to understand what's happening. So in this equation, just for CO2 emissions, you have the number of people, the units of capital per person, which is determined by cultural norms, and then the energy required per capital unit, and then if you have fossil fuels as opposed to renewable energy, this is a fraction of energy from fossil fuels. So this is just the impact from CO2 emissions. We have all of these other environmental impacts that have been identified with all of the things that we do in our, or obtain in our daily lives. So for each of these, there are impacts in what we do. And if you take a look at an iPhone 3G, and this was a structure where it's pulled apart, you can see here, there's some regions here that are gold. So even if you look, okay, now you're going to expand this to not just the environmental sustainability, but we expand it to societal issues as well. And also economic issues. And we start looking at gold, silver, and platinum, and the content in these different electronic devices. So you can see here, this is weight percent. So let's go to the mobile phone. 5% iron, 1% aluminum, 13% copper, 56% plastics, and 1,380 parts per million. So that is a 1,000 or a milligram of silver, less than 1 milligram of gold, and in palladium. If you go back and look at, okay, we have recycling. So now we're going to be able to take these materials, and we'll be able to take these materials back and recycle them. So if we recycle them, then we won't be using as much natural resources because we're putting them into back into the stream. The polymers are not where the value is. People are not basically going to be recycling based on the polymers. If we expand it here, 4%, or see in the mobile phone again, 0% of the recycled value is based on the iron, 0% on the aluminum, 7% of the copper, and 93% is based on the precious metals. When they're there, it's much less than a gram out of a whole cell phone. So here are some of our gold. They're there at the microgram level, or sorry, the milligram level. So there's gold. The gold is present in a number of different places in the electronics. These are called wire bonds, where this is a computer chip and the wire bonds connected to the outside and in the cell phone. Here are pictures of some of the wires that are attached to the component. And now we see the remaining amount of gold present in the material. That was providing the gold, the palladium, and the silver provided most of the worth in the end. If we look at this and see, all right, what is the environmental impact of the different materials if you take mining into account? This is some work by Schuhmann and Bagalini. This is polymers. This, in terms of fraction by weight, for gold and palladium, you can't even see this on the pie chart. But in terms of environmental impact and impact on society, it has the highest impact. So when we're designing materials and designing products, we have to take these kinds of things into account, as well as taking the societal issues into account as well. So a few weeks ago, I was in Colombia for the U.S. Columbia, or a workshop on nanotechnology as part of the Purdue-Columbia partnership. And that, on the top left, is a picture of current gold mining technology in Colombia. And the bottom right, that is the technology that is being used in the Democratic Republic of Congo. In the bottom left, that is informal recycling that's occurring in China, and that's called the cable burning village, where all of our electronics or many of our electronics that are recycled here that we think that we are being so virtuous by recycling, they end up there where the toxic polymers are burned off. And then the top right-hand side is aqua regia containers to strip off the gold. So I'm going to go through here, excuse me. So we have been working very closely with INEMI. I mentioned INEMI before. INEMI is this group of electronics manufacturers that are working very hard to develop new technologies. Their primary focus is technological. It has the Dell, Intel, they want to sell product, but they also want to try to improve the sustainability of their products. So they end up doing roadmaps. They set priorities for R&D, and they also have been providing, this has been instrumental in providing reliability and manufacturing knowledge necessary for the worldwide conversion to lead-free, and is trying to help with other systems as well. And so again, these are the companies that are part of this. They're beginning to recognize some of the issues that are associated with sustainable electronics and their personal responsibilities to places in other parts of the world. Here are some of the supplier members. And so here, Texas Instruments, those are probably the ones that, one of the few ones that is sort of a household name. And then the research institutes and university members, and Purdue has been a member for 7.5 years. And actually, Purdue joined INEMI the month before I started, so it was already underway. So one of the things that INEMI is working on is trying to define what it really means to be sustainable. So this is from the EPA and INEMI roadmaps. And these are some of the things that make sustainability so challenging. So this is the first thing that has to happen, and that is business decisions are aligned with sustainability objectives. And when we first unveiled this to some people in INEMI, the broader group, they said, didn't you mean that sustainability decisions are aligned with business objectives? I said, no. That's where we are right now. It has to be the other way around. All life cycle costs are internalized in the products. So I put this quote in the abstract. It said, externalities are impacts generated by one economic actor which are felt by others, but the market doesn't bring these impacts back to affect the actor that originated them. So by my designing with gold and not worrying about where the gold comes from and what happens to the people who are mining the gold, I have used the gold as I have completely externalized the cost to them. Because I'm not taking into account whether they have clean water or food or shelter. I don't have an obligation towards them that I have acknowledged. And so by internalizing all of the life cycle costs into the products, what we're doing is that we are really valuing the product. We are saying that the money that I'm using is going to be used to help to provide these resources and these natural rights to other people. The right to have clean water and education. And so our cell phones, if that were true, our cell phones probably wouldn't cost, well, how much did your last cell phone, who bought a cell phone in the last 2 months? And how much did your cell phone cost? $330. Newest technology. Which kind did you get?
Nexus 4.
Okay. And probably if we internalized the external costs, those costs would be much higher. So the cost of assembly for an iPhone 5, the amount they're paying to China for all those assembly costs is less than $9. And this comment about internalizing the cost actually came from a major cell phone manufacturer said this is what it's going to have to look like. That the decisions are transparent, that companies, consumers, and all people in the supply chain are accountable, and that ICT enables smarter use of natural resources. And then we say, but there's more. So for things to be sustainable, all ICT hardware is manufactured in facilities with best-in-class safety and health, safety, and environmental standards globally, with employees earning a living wage, no forced labor, no forced overtime, no child labor, no discrimination, and workers have freedom of association. No chemicals or material selection is made without an alternatives assessment or the substances on the good list. And there aren't many things on the good list. Hazardous emissions to air, water, land are eliminated, resources aren't wasted, and people and communities benefit from the resources that are used from wherever they are. So in trying within the IGERT to understand what the 3 pillars are of sustainability and incorporate these and actually still have people manufacture something and people live a better life, we have been trying to figure out how to have these dialogues to try to bring some of these things into reality. So within the IGERT, it's Purdue and Tuskegee. It's with INEMI plus 5 additional corporate members. We have 5 international academic partners, and it will provide 28 two-year fellowships over 5 years. We have an external advisory board. And so our vision is to create a new integrative collaborative model for graduate research and education needed to enable meaningful and measurable improvements in the global sustainability of electronics. I'll share with you at a different date the different topics that we proposed. They're at the highest level: polymers from nature for construction and disassembly, sustainable product design and manufacturing, system and supply chain issues, including consumer behavior and legal issues and regulation. And there are a lot of different things that we are asking our students to do. We want them to become decision makers using input from interdependent dynamic systems that affect sustainability. And some of these agree with sort of the Engineer 2020 team-based, cross-disciplinary, work and act globally, and work and develop education possibilities globally. But the things we're really trying to teach them at the higher level is how we can all agree on common goals, and these are common goals with the industry, with NGOs, and how to have difficult yet productive conversations with people who are trusted partners. And we hope very much to be able to make progress through this. So right now we have this incredible group of trainees and IGERT associates who are part of this. See some of them up there. Friends of IGERT associates as well. And they have interdisciplinary teams of faculty members working with them. And through this, we hope that we will be able to help the industry make some good decisions. So if we go back to the lead-free problem, so they banned the use of lead in electronics. At the same time, when they banned the use, they also said, we're going to recycle all of this, and we're going to make it very restrictive for processing the electronic waste in our own countries. So they set the stage in doing that to lead to waste being shipped to China and developing countries. So they solved a technical problem. We became lead-free. No, we were able to do that. And they concentrated their recycling in the countries with the weakest recycling environmental regulation. Ultimately, it may reduce lead poisoning during this informal recycling, but not yet. The new lead-free electronics aren't coming into the waste stream yet. Maybe a few of them are. You know, the cell phones that, I don't know, somebody dropped and broke the screen on their iPhone 5 or whatever. But it's going to be a while before the electronic waste stream actually becomes lead-free, and they're continuing to be poisoned. In lead-free, tin whiskers are a problem, which is you have these thin layers of tin films in electronics, and in sitting there, because of some stresses that build up at room temperature, they make centimeter-long tin needles that cause short circuits. If you added lead to the system, the problem went away. And because lead has been banned, we can't use lead anymore for that. And there is no other element in the periodic table that can work like that, except perhaps cadmium, which is worse. And then there are other reliability issues. And then it means if we can't use lead, and it used to be about 40% lead, now we use more tin. And tin is a conflict mineral. And we're running out of tin. And there's more silver mined, and then dot, dot, dot. So what we're trying to do is understand sustainability from not just one perspective, not just from a technological perspective, but from a much broader perspective, not just as engineers, but really as citizens of the world who are trying to protect the future generations, our children, and make it possible for them to have good and healthy lives. So, thank you very much.
Professor Handwerker will be happy to answer questions.
So Carol, that was inspirational. So in 1979, when I was a senior student at the University of Queensland, I did an environmental engineering course taught by a professor who was into environmental economics. We talked all about externalities. We had a nice textbook about it. I don't see a lot of action. I mean, we don't have trading of carbon and other, so I guess one of the, so can you have examples where it's actually in practice, that sort of thing is actually made its way into practice? And one, if I was to take a negative take-home message for your talk, it might be stop doing anything until we've sorted out various, until we've got world population under control, until we've got free trade agreements in place, until we've got some, stopped all the wars, if you like. So obviously that's not a practical way to go forward. Have you, are we making progress through this mire towards sustainability?
Well, I do believe that individuals and groups can make progress. And I believe there is something called a tipping point where one can begin to make much more rapid progress when you get enough people and enough organizations working in a given direction. So it's not, one could get very discouraged, depressed even, about the prospects, but I think that it is possible because people are able to think beyond just their own basic or own personal needs, or we'll sort of say capitalistic needs. That there's a tragedy of the commons scenario where it says that if you have a limited pool of resources and you have people using those resources, that people will use them. If they're not controlled, they will use them till they're all gone. And what people have found, and Eleanor Ostrom was one of those people, she came to Purdue last year and gave a talk, she found that there is self-organization that can happen, that people will regulate themselves to try to share the resources so you don't end up having these these externalities. But it takes practice. We have to do it every chance we get to internalize the cost. So that's why we need people in other kind of disciplines other than engineering to be able to help us with that. Yeah, there are fair trade coffee. You know, fair trade. There is apparently a new movement in Colombia and Peru for fair trade gold. So there are best practices or minimum allowable practices, and so they say these people deserve this amount of resources, and we will only buy things that way. And that's the conflict minerals. That's what they're trying to do too.
Has someone worked out the very practical or the nuts and bolts example of a single item of recycling, just to get an example in terms of basic costs, internal and external costs?
No.
There must be a billion of these every year that go into a recycle bin of one kind or another. And let's say that there's $1 that's gold and precious
So
metals.
people have done the economic assessments of those.
Right.
They've determined what sort of
Just on the economics alone, are the economics favorable for recycling gold, for example?
yes.
Okay.
But if, for example, you send the cell phones to China, they're not going to be using state-of-the-art smelters to remove the gold. They end up actually getting less of the gold out than they could if they used state-of-the-art smelters. So people have done those kinds of comparisons, and all of those actually make a profit. But the maximum amount is obtained by the highest technology. The full externalization, though, or the internalization, nobody's done. To say, okay, what societal cost should gold have in dollar terms if it's actually going to be used in something. Anyone else?
I have a question. I noticed early on, North American Rockwell was involved,
Yep.
but later they were not. I was just curious why, if there is a reason.
Actually, they're not consumer electronics. They're military.
That's correct.
And so they were concerned about it originally because it was making all electronic products in the United States. So that's when lead was going to be banned. But it was banned in a manufacturing sense. So it was from an OSHA sense, not a waste point of view. In other work, in the lead-free solder work, actually in most of those other projects that I showed you up there that we've been involved in, we've been working very closely with Rockwell.
Okay.
So Rockwell Collins in Iowa, we have multiple papers with Rockwell.
Thank you.
Any more?
There's going to be a quiz on this.
Oh, they can give the test. They're the IGRT students. Will you raise your hand? Some of who are here? Great. So you know them by face. Thanks. Okay, thank you very much.